Okay, review for tomorrow and Friday's test. Weather and erosion. So you got to know your agents of erosion. And you already did this with Mr. Updike on Monday, but regardless, okay, you need to know gravity, wind, water, and ice. Okay, you got to know all four agents of erosion. Do you need to know the sediment shape and pattern and deposition? You need to know for water and for ice, guaranteed. I'll tell you right now, the first question on the test is how and what the sediment shape is for one of the four agents of erosion. Okay? First question on the test. Do you need to know what a talus pile is? No, but it is a pile of debris at the bottom of a cliff. Do you need to know what shape a river valley is? Yes, it's a V shape. Rivers, V in the word river, V for V-shaped valley. Do you need to know what levees are? Yes, levees are naturally forming higher regions next to rivers that flood and deposit sediments next to the river. Okay, delta. You need to know what a delta is. It's another landform. It's where the river comes out, mouth spreads out, deposition occurs, big giant fan-shaped deposit. We watched the delta form on the stream table a couple weeks ago. You need to know what a floodplain is. Large flat area next to a river that floods. Done. Okay? You need to know the Finger Lakes. We live in the Finger Lakes area. If you don't know that, then that's pretty sad. Okay, moraines. Moraines are long ridges of sediment, okay, which are poorly rounded and unsorted. You need to know what a drumlin is. It's steep on the north side, tapered on the back side. All glacial valleys are U-shaped, and they have rocks have parallel scratches into them, okay? So, sand dunes, not on the test. Sorting for wind, yes, it's angular and sorted. Landslides are caused by what agent of erosion? Gravity. So, picture. Where is the beach going to widen? It's going to widen at D and it's going to widen at B. Why at B? There's a longshore current carrying the sand down the beach. This jetty or groin is going to catch the sand and it's going to form it's going to widen the beach at B. Okay? Continuing. Rivers and deposition. Okay, so you need to be able to figure out the speed of what sediment is deposited at a given speed. Okay? Describe the sediment in terms of shape. Just went over that on that note sheet that you guys did with Mr. Updike. What point is the river carrying the most sediment? A through D. Well, at the very end of its channel, it's going to have the most water, so thereby it's going to have the most sediment, so B, E. How would you describe, let's see, what's the shape down here? What is this down here at letter E? What is this deposit? This is a delta. Okay? The rivers that go or lead into the Mississippi River are tributaries. Okay? So, Missouri, the Ohio, the Arkansas River, the Red River, they're all tributaries of the Mississippi. Do you need to know the names of the rivers? No, you don't need to know the names of the rivers. You just need to know the tributaries. This pattern is called the dendritic pattern. So if I look at this one, I look in the low spots, and I can see that's where the rivers will be. So in the areas where there's white, that's the valleys. The valleys are where the river's going to be. So I will notch there, a little notch there, a little notch there, and the white streaks are where the river, because those are the lower areas, that's where the valleys are, and that's where the river's going to be. So if I had to imagine this picture and match it up with 1, 2, 3, or 4. Okay, so here's the picture. What matches up 1, 2, 3, or 4? The one that has it in straight lines, that's going to be number 4. Okay, that gives you a good context of how the streams are drained in that region. Okay. The easy one would be the mountain flows away, so it looks like number 3. Okay. Watersheds. Let's see here. Why are the lines where the lines are? Because of two things. Because of the hardness of the bedrock and the elevation of the land. Why is it that there's a lot of different divides in the Adirondack Mountains? Because they're mountains. There's a lot of areas where the water drains in different directions in the mountains. Okay, you got the Champlain, you got the Hudson, you got the Ontario, and you got the St. Lawrence. Lots of different ways the water can drain. Glaciers, U-shaped valley. How would I describe the sediment? Unsorted and poorly rounded. Continuing. Okay, so how is this glacier moving? It's spreading outward. Valley glaciers move downward just like rivers because of gravity. This is a continental glacier. Continental glaciers move outward because of they're being thickest in the center or thickest towards the center and spreading outward like that. It's similar to a pancake, or it spreads out. Okay, so where does this form? It forms at high latitude. Okay, valley glaciers form at high altitude. So high latitude, that means Greenland, Antarctica are both high latitudes. The tippy top and bottom of our planet. Okay, so if I looked at the thickness of the point A, you should be able to figure out that because it's an isoline map, no problem. You should be also able to explain why the glacier forms. Glacier forms because more snow falls in the wintertime that can melt in the summertime. It's as simple as that. Okay? Continuing, if I carved into the ice, I'd be able to study past atmospheric conditions. What? Yeah, that was in the notes. Ice from glaciers is a time capsule. The ice forms, there's bubbles trapped in the ice, and that tells us what the atmosphere was like 100 years, 200, 1,000. We can do drill core samples or ice samples for up to 3 million years in Antarctica. Okay? Way far back, we can figure out exactly what the atmosphere is like because those little bubbles are a little tiny time capsules. So where is there more erosion on this diagram? More erosion occurs at X because it's on the outside of the turn, just like water slides. More erosion happens on the outside of the turns, less erosion happens on the inside of the turns. Okay? Continuing. I think we talked, how are you going to get the water to flow faster? There's 3 ways you can get the water to flow faster. The river goes straighter. Just like in our stream table, if I tilt it at a greater slope will make this water flow faster. Okay? So the angle in which the water flows down the river. Or, last but not least, going back to the stream table lab that I did, if I put more water in the bucket and the water flows out of the tube faster, meaning greater discharge, okay, greater volume, that means that that river will flow faster. More erosion than deposition. Again, erosion is carving away, deposition is depositing. Okay, you have 31 multiple choice questions tomorrow, and you have a dozen fill-in. Okay, let's talk about fill-in questions. You had to imagine what a stream bed, really quickly, these have one value that are all the same. Different sizes, but there's one value that's all the same, and that's porosity, the pore space in between. Lots of little spaces in the small one, only a few big spaces in the big one. This little spaces equal to big one, big spaces, they're all equal porosity, so long as they're well sorted. Okay. So, I had to sketch the stream channel on this one, okay? Between D and C. It drops down slow and goes up. Make sure that you know that your stream bottoms go down like the floor of the pool. They don't go up, okay? It's the one time you're going to be drawing profiles where they go down and easily to understand because the depth increases, okay? So, continuing. Let's take a look at the reference tables. You need to tell me where or why the Catskills aren't mountains. Okay, so I find here Catskills are part of the Allegheny Plateau. That means they're sedimentary rock. That's why the Catskills geologically are not mountains. They're not distorted rock either. They're distorted sedimentary rock either. They're plain old flat-lying sedimentary rock, okay? It's just heavily dissected. What rivers have a watershed within the Catskills? Go to page 3. You look in here. I find the Delaware River and the Susquehanna come up into this area, okay? So those are quality answers. Not to say I'm giving you anything to do that might be on the test. Tomorrow, particle size, transportation. Okay, so it's 100 centimeters per second. 100 centimeters per second is right here. So I'm going to go up, I'm going to come over, and I'm going to find that pebbles, sand, silt, and clay can all be transported by the river. Okay? What's the exact size? The exact size would be about 3 centimeters in diameter. Okay? Let's talk about what happens if the stream is flowing at 5 centimeters a second. Okay? So I come up, I go over, I have sand, silt, and clay. What's the approximate maximum size? Just smaller than 0.1 centimeters in diameter. Okay? So that's the material that can be transported in the river. Okay? That will be on your test at least twice in multiple choice form and in written, so you've got to be prepared to do both of them. Okay? Another example, okay, let's say that sand is being settled out. So I come over here, find sand, I come down, I have a speed of approximately 2 centimeters a second. Okay? That's the way in which we find particle settling time, okay? Let's say that we had an object 10 centimeters in diameter. What's the speed? So 10 centimeters in diameter, I go over, I go up. It's slightly less than 200 centimeters per second, okay? That type of question will be there. Let's talk about weathering, okay? How is it that ice is weathering our roads right now? Because it's the expansion of the ice, then the melting. Not that there's been a lot of melting this winter, but melting, then refreezing, then melting, and every time it melts and refreezes, it opens those cracks up bigger, and that's how we get potholes on the wonderful roads that we have here, okay? That goes over a lot of what is on your test tomorrow. I hope you guys do well. I'll be here, ready and waiting. You, like I said, 31 multiple choice and a dozen fill-in, okay? Good luck, and I'll see you tomorrow.